cause space experts have raised a ruckus around town. This is their blessing from heaven. A new section in cosmology has opened up. Proxima Centauri b is an Earth-like planet that circles around the nearest star to the planet Earth. What an occurrence! The planet Centauri b looks like Earth and spins around the closest star to our reality. How amusing that mainstream researchers have been stunned by Michio Kaku's finding of unseen planets that are considerably more ideal for life than Earth. There are planets in our universe that look like Earth, called livable exoplanets. As you may currently know, albeit the Earth's current circumstances are by and large good for life, why not go for the gold? Best envision universes with a lot of water, fewer deserts, adjusted temperatures, and more land. Heaven exists out there somewhere, but remember that researchers have recognized some serious competitors for the fate of humankind. So, remember that we should show up as we research these fascinating universes and expected routes to them. Now, the blessed vessel of stargazing is to see the nearest Earth-like twin, a doppelganger in outer space, and now we've nailed it, incredibly tenable planets. Prestigious physicist and prime supporter of string hypothesis, Kaku, has high expectations for humankind's future. He feels that mankind can turn into undying and maybe advance to the point where, as a two-planet race, we are overcoming different universes. This is pivotal if supervolcanoes, ice ages, or shooting star influences make horrendous harm to Earth. The first stage is to leave Earth and populate different planets in light of the fact that the Sun will consume Earth in 5 billion years. In the distant future, we could find a planet in the cosmic system that is like Earth and settle there. Anyway, we might hold back nothing, tenable universes rather than just Earth-like planets. Contrasted with Earth, these divine universes could have even more potential to support life. This thought was set up by Renee Heller and John Armstrong in 2014, who asserted that deciding a planet's genuine livability requires something beyond deciding whether it is situated inside its star's tenable zone. The quest for incredibly livable planets is not very obvious. Earth, the only planet we know to be occupied, has the optimal physical and chemical circumstances for life. Liquid water is important for life, which is the reason we look for exoplanets that look like Earth. Regardless, different researchers battle that, in contrast with Earth, different sorts of planets could provide similarly good or far superior conditions for life. The quest for incredibly tenable worlds invites the notion that planets may not actually need to be comparable to Earth to support life. Rather, they might present surprisingly better opportunities for the evolution and development of a wide assortment of species. A superhabitable world, for example, an Earth-like planet or moon, might host a more diverse range of flora and fauna than Earth. Notwithstanding the conviction that Earth is the cutoff of planetary tenability, there could be more ecological kind disposition toward life in such planets. Features of very tenable planets indicate that not every rocky planet situated in a livable zone might be viewed as tenable, of course, as found in the interior expanse of Jupiter's moon Europa, where flowing warming, for example, might make Earth-like or frigid worlds bearable beyond the star livable zone. Our fixation on Earth-like universes could be a deterrent to our examination of exobiology and all of its interesting conceivable outcomes. An adjustment of perspective is necessary to distinguish very bearable universes. Organic variables ought to be focused on above geocentric or human-centric ones. Astrobiologists imagine that we could disregard elective choices, such as universes that are even better than Earth, since we are so centered around viewing as a second Earth. The possibility that Earth is the most tenable planet in the universe is raised into doubt by the presence of superhabitable universes. Superhabitable planet factors, with an end goal to extend our search, Heller and Armstrong recommended making an exoplanet profile that incorporated various factors, including star type, planetary mass, and system position. Nowadays, life is being sought after past yellow dwarf stars like the Sun, planetary systems connected to orange dwarf stars, which are more modest, fainter, and colder than our Sun, are concentrated by researchers with lives crossing from 20 billion to 70 billion years. Orange midget stars provide planets in their livable zones with enough of a chance to help the rise of life and amass biodiversity. Orange dwarfs have a more drawn-out life expectancy than Earth, which is essential considering that complicated life on Earth has only arisen after 3.5 billion years. Despite the fact that older planets have benefits, they should not be excessively old. These planets eventually run out of their natural geothermal heat reserves and they're preserving geomagnetic fields. Between 5 billion and 8 billion years old is the perfect age range that specialists have proposed. By contrast, Earth's age is around 4.5 billion years. Size and mass are also important. A planet's mass and size straightforwardly affect its ability to support life. A planet greater than Earth would have a surface area that is tenable and could uphold a more expansive and stable climate. There may be ideal circumstances for life on a planet 10% greater than Earth. If a planet is half a mass greater than Earth, the longer radioactive decay time frame inside the planet will provide a consistent heat source. This would draw out the time frame that the planet's liquid center and essential magnetic field remain in a salvageable state, increasing the window of opportunity for the development and growth of life. Moreover, a planet with more mass will experience stronger gravitational pull, which will help retain the planet's atmosphere. The air is more helpful for life the longer it persists. If we somehow manage to visit such a planet, expanded gravity would make it more difficult for individuals to stroll around, but this is a minor issue compared with the difficulty of getting to such a world. In any case, very reasonable universes could exist if they show a modest 8 degrees Fahrenheit temperature increase over Earth. On Earth, larger equatorial jungle areas support more biodiversity. The warm, damp circumstances of tropical rainforests are home to an amazing assortment of species. However, due to the advancement of deserts brought on by increasing temperatures, hotter planets may require more precipitation. Water is vital for all life on Earth and is a crucial component in the search for planets that could support life. Besides, planets with Earth-like land masses that are isolated into smaller landmasses would provide a more positive environment for life. In our own reality, a greater assortment of life can be found in the shallower regions of our oceans than in the deepest ones. As a result, planets with smaller water masses might be more reasonable for supporting a wide variety of life forms. Imminent target. Researchers are still looking for these markers, regardless of whether some of these conditions are still beyond the scope current observational capabilities. Alpha Centauri b ended up being a particularly interesting objective in this search for the discovery of a very bearable planet. Still, none of the planets in Alpha Centauri b have been definitively proven to be very tenable. Proxima Centauri is a red dwarf star that is just 4.2 light-years from Earth and may have livable or maybe superhabitable conditions. Tenable planets. Proxima Centauri b. Proxima Centauri b is one planet that resides in the red dwarf's habitable zone. Proxima Centauri b can possibly support life. However, there are major hardships in the manner the planet is intense to live on because of tidal locking events and the radiation of the star. Proxima Centauri's UV radiation might cause the ozone layer to be disrupted, which could result in perilously high UV radiation levels. Because of its tidal locking, Proxima Centauri b isn't subject to conventional day-night cycles. However, if it harbors seas, tidal forces could lead to drying and flooding cycles in coastal conditions, potentially fostering the development of biological rhythms akin to day-night cycles. Exploring universe expansion. As of now, there are over 5,000 confirmed exoplanets in our galaxy alone, and numerous more candidate discoveries are simply waiting to be observed. It has been suggested by Washington State University scientists that there might exist exoplanets with conditions much more favorable for life than our own. 24 possible very habitable candidates were chosen by specialists from the long list of over 4,500 known exoplanets. Koich 57151 is a remarkable competitor. It is situated around 700 light-years from Earth. This candidate planet orbits a yellow dwarf and is believed to be 6.5 billion years old. It has an average surface temperature of around 80 degrees Fahrenheit and a diameter that varies between 0.72 and 1.29 times that of Earth. Exoplanet investigations and the future. Specialists contend that within the currently known exoplanet population, very habitable planets might exist, notwithstanding their distance. Future space observatories like the James Webb Space Telescope aim to analyze these distant planets' environments and search for potential biosignatures. New strategies for enlightening these worlds are made possible by the European Space Agency's Plato Space Telescope and NASA's LUVOIR Space Observatory mission. Researching very habitable planets. Humankind's future may depend on planets like Proxima Centauri B, which resemble Earth and revolve around the closest star to our reality. How amusing that the academic community has been stunned by Michio Kaku's finding of unseen planets that are potentially better for life than Earth. There are planets in our universe that resemble Earth, referred to as habitable exoplanets. As you may already know, although Earth's climate is generally favorable for life, why not strive for the ideal? Imagine worlds with plenty of water, fewer deserts, regulated temperatures, and much more. A land of paradise exists somewhere, who knows where? Nonetheless, remember that researchers have identified several serious contenders for the fate of mankind, so keep that in mind as we explore these fascinating worlds and potential paths to them. Incredibly habitable planets. Eminent physicist and co-founder of string theory, Michio Kaku, has high hopes for humanity's future. He envisions that humankind can become undying and perhaps advance to a point where we, as a two-planet species, are conquering other worlds. This is crucial in the event that supervolcanoes, ice ages, or asteroid impacts cause catastrophic damage to Earth. The primary stage is to leave Earth and populate other planets, as the Sun will consume Earth in 5 billion years. In the distant future, we could find a planet in the galaxy that is similar to Earth and settle there. However, we might strive for habitable worlds rather than just Earth-like planets. Compared to Earth, these celestial worlds could have much more potential to support life. This idea was proposed by René Heller and John Armstrong in 2014, who claimed that determining a planet's true habitability requires more than simply assessing whether it is situated within its star's habitable zone. The search for incredibly habitable planets. It is not entirely obvious that Earth, the only planet we know to be inhabited, has the ideal physical and chemical conditions for life. Liquid water is essential for life, which is why we look for exoplanets that resemble Earth. However, other researchers argue that, compared to Earth, different types of planets could provide similarly positive or even better conditions for life. The search for incredibly habitable planets suggests that planets may not need to resemble Earth to support life. Rather, they may offer surprisingly better opportunities for the development and evolution of a wide variety of species. A potentially habitable world, like an Earth-like planet or moon, might harbor a more diverse range of flora and fauna than Earth. Despite the belief that Earth is the benchmark for planetary habitability, there may be more ecological friendliness towards life on such a planet. Elements of very habitable planets. Not every rocky planet located in a habitable zone can be considered habitable by default, as seen in the icy moon of Jupiter, Europa. Tidal warming, for instance, may make icy or ocean worlds habitable beyond the star's habitable zone. Our fixation on Earth-like worlds could be a hindrance to our exploration of exobiology and all its intriguing possibilities. A shift in perspective is necessary to recognize incredibly habitable worlds. Biological factors should be prioritized over geocentric or anthropocentric ones. Astrobiologists feel that we may overlook alternative options, such as worlds that are surprisingly better than Earth, because we are so focused on finding a second Earth. The notion that Earth is the most habitable planet in the universe is challenged by the existence of superhabitable planets. Universe's superhabitable planets, factors with an end goal to extend our search. Heller and Armstrong recommended making an exoplanet profile that incorporated various factors, including star type, planetary mass, and system position. Nowadays, life is being sought after. Past yellow small stars like the Sun, also planetary systems connected to orange small stars, which are more modest, fainter, and colder than our Sun, are concentrated on by researchers, with lives spanning from 20 billion to 70 billion years. Orange dwarf stars give planets in their habitable zones enough of a chance to support the development of life and amass biodiversity. Orange dwarfs have a longer life expectancy than Earth, which is significant given that complex life on Earth only arose after 3.5 billion years. Despite the fact that older planets have benefits, they should not be excessively old. These planets ultimately run out of their geothermal heat reserves and their protective geomagnetic fields. Between 5 billion and 8 billion years old is the perfect balance, which is the best age range that scientists have proposed. By contrast, Earth's age is around 4.5 billion years. Size and mass. A planet's mass and size have a direct influence on its ability to support life. A planet greater than Earth would have a livable surface area and could uphold a more extensive and stable atmosphere. There may be good conditions for life on a planet 10% greater than Earth, and if a planet is half a mass greater than Earth, the longer radioactive decay period inside the planet will provide a stable heat source. This would extend the time that the planet's liquid core and protective magnetic field remain intact, increasing the opportunity for the rise and development of life. Furthermore, a planet with more mass will experience stronger gravitational pulls, which will draw out the planet's atmosphere. The atmosphere is more helpful for life the longer it persists. If we somehow manage to visit such a planet, increased gravity would make it more challenging for individuals to walk around, but this is a minor issue compared to the difficulty of reaching such a world. In any case, the temperature on very habitable worlds could exist if they show a modest 8 degrees battle temperature increase over Earth. On Earth, larger equatorial areas support more biodiversity. The warm, humid conditions of tropical rainforests are home to an amazing assortment of species. However, due to the development of deserts brought on by rising temperatures, hotter planets could require more precipitation. Water is crucial for all life on Earth and is a vital component in the search for planets that could support life. Moreover, planets with Earth-like bodies of land that are isolated into smaller continents would provide a more optimal environment for life. In our own reality, a greater variety of life can be found in the shallower regions of our oceans than in the deepest ones. As a result, planets with smaller water masses might be more suitable for supporting a diverse range of life. Structures, planned objectives, and present searchers. Scientists are still looking for these markers, even if some of these conditions are still beyond the scope of our current observational capabilities. Alpha Centauri b ended up being a very intriguing objective in this inquiry for the discovery of a habitable planet. Currently, none of the planets in Alpha Centauri b have been proven, let alone any very habitable planets. Proxima Centauri is a red dwarf star that is only 4.2 light-years from Earth and may have habitable or perhaps superhabitable planets. Proxima Centauri b is one planet that resides in the red dwarf's habitable zone. Proxima Centauri b has the potential to support life. However, there are significant major challenges in the way the planet is conducive to living due to tidal locking events and the activity of the star. Proxima Centauri's UV radiation might cause the ozone layer to be disrupted, which could result in dangerously high UV radiation levels. Because of its tidal locking, Proxima Centauri b is not subject to standard day-night cycles, but if it harbors seas, tidal forces would bring about drying and flooding cycles in coastal conditions, encouraging the development of organic rhythms similar to day-night cycles. Exploring the universe. At present, there are more than 5,000 confirmed exoplanets in our system alone, and many more candidate discoveries are just waiting to be observed. It has been proposed by Washington State University scientists that there might exist exoplanets with atmospheres much more conducive to life than our own. 24 possible very habitable candidates were chosen by researchers from the long list of more than 4,500 known exoplanets. KOI 57151, an outstanding competitor, is in orbit around a red dwarf star. Its temperature is imperceptibly lower than Earth, and its age is in the optimal zone. That being said, Earth is around 2,965 light-years from it. Found around 700 light-years from Earth, this candidate planet orbits a yellow dwarf and is believed to be 6.5 billion years old. It has a typical surface temperature of around 80 degrees Fahrenheit and a width that fluctuates between 0.72 and 1.29 times that of Earth. Exoplanet investigation future. Researchers contend that within the currently known exoplanet population, very habitable planets might exist despite their distance. Future space observatories. like the James Webb Space Telescope, plan to analyze these distant planets' atmospheres and search for potential biosignatures. New strategies for observation are being made possible by the European Space Agency's Plato Space Telescope and NASA's Louvois Space Observatory mission. The choice of targets for observation is critical. While we wait for the upcoming generation of satellite telescopes to launch, it is essential not just to focus on finding a second Earth. It is crucial to consider the possibility that there are planets out there that could support complex life even more than our current understanding. We might interpret the potential habitability of exoplanets as we expand our horizons and concentrate on the most promising candidates. This will also improve the likelihood of making significant discoveries. The search for very habitable planets expands our perspectives and increases the probability of major discoveries. A planet might be unwelcoming even when it meets the essential conditions for livability. In any case, the quest for these worlds drives astronomers and futurists to explore the universe and search for new opportunities for the future of humanity. Will humankind ever make it to these distant, very habitable planets? Subscribe, like, and comment to get future updates about our journey into the unexplored world.